October 1944, the Pacific Ocean. The night sky burned red as American battleships lined up across the dark waters like sleeping giants. The sea was calm, but beneath that silence, thousands of sailors waited for one order. For months, Japan had boasted that its island defenses were impenetrable, guarded by the strongest coastal guns, the mightiest fortifications ever built. But the U.S. Navy was about to test that claim with a weapon so devastating it would redefine naval warfare forever. From the decks of the USS Iowa, USS New Jersey, and USS South Dakota, 16-inch guns, each the size of a city bus, turned toward the enemy shore. Every shell weighed as much as a small car, each capable of punching through 30 feet of concrete. When the first barrage began, the ocean itself seemed to tremble. The sound shattered windows 50 miles away. Japan's coastal defenses didn't just crumble, they vanished. Entire fortifications disappeared in seconds. Observation posts melted. Communication lines went silent. And as the smoke cleared, Japanese officers stared at the horizon in disbelief. The invincible had been shattered by American steel and precision. This wasn't just bombardment. It was the moment Japan realized that industrial power and engineering genius had built weapons beyond imagination. Anchor stay till the end, because this isn't just the story of America's guns. It's the story of how raw engineering turned the tide of the Pacific War. March 1941, New York Naval Yard. The world stood on the edge of total war. Across the Atlantic, Hitler's armies rolled through Europe like an unstoppable tide. In the Pacific, Japan's empire stretched wider every month, swallowing territories under its rising sun flag. But in the shipyards of America, something was stirring, something vast, cold, and made entirely of steel. Workers in worn coveralls and hard hats climbed over the hull of a new kind of battleship, one unlike anything the world had ever seen. Her name, USS Iowa, BB-61. At 887 feet long and armed with 9.16-inch/50 caliber Mark 7 guns, she was a moving fortress, a city on the sea that could throw a 1-ton shell 23 miles with pinpoint accuracy. To the average worker tightening bolts or welding seams, it was just another job. But to the men in Washington watching the Japanese fleet expand, the Iowa class represented something far greater. A promise that America would never again be caught unprepared. As the last plates were fastened and the black hull reflected the morning sun, the ship's designer whispered, "These aren't just ships, they're symbols. Symbols of a sleeping industrial giant about to awaken." When Japanese bombs tore through the Pacific Fleet, that giant opened its eyes. The battleships that lay smoldering in the harbor became a rallying cry, and the unfinished Iowa became the embodiment of vengeance forged in American steel. Within months, the sound of hammers, welders, and cranes filled shipyards from Newport News to San Francisco. Engineers worked day and night under floodlights. Blueprints were redrawn, holes lengthened, and guns calibrated for power the world had never seen. While Japan celebrated its victories across the Pacific, America was already building its revenge, one rivet at a time. August 27, 1942, New York Harbor. Crowds lined the waterfront as the newly completed USS Iowa slipped into the water for the first time. Bands played, flags waved, but every man watching knew this wasn't just another naval launch. This was America's reply to Pearl Harbor. The battleship gleamed under the morning sun, her hull painted jet black, her guns pointed toward the horizon. She was beautiful and terrifying. On her decks, sailors whispered about the weapon that defined her, the 16-inch/50 caliber Mark 7 naval gun. Each gun stood 66 feet long, its barrel bored to fire a 2,700-pound armor-piercing shell at nearly 2,500 feet per second, faster than the speed of sound. At full range, it could hit a target 23 miles away, farther than the eye could see. It took nearly 80 men to operate a single turret, and when one fired, the entire ship shuddered like the earth itself had exhaled. To Japan, this was a nightmare in motion. Intelligence reports filtered back to Tokyo, describing the Iowa class as floating mountains of steel. But the truth was worse. These weren't just ships of war. They were the physical embodiment of American industry. Factories from Detroit to Pittsburgh had turned from making cars and bridges to producing armor plates, gun barrels, and shells by the millions. Women filled the shipyards, welding bulkheads and riveting decks, their hands crafting the steel beast that would carry America across the Pacific. As the sun rose over the Marshall Islands, the Iowa's guns fired their first salvo in anger. 9 thunderclaps echoed across the sea, and the horizon turned white with smoke and fire. Japanese coastal batteries that had taken years to build were gone in minutes, reduced to dust by the first American 16-inch naval bombardment of the war. The age of air power had begun, but for a brief and unforgettable moment, the oceans still belonged to the giants, and they had just awakened. October 25, 1944, Leyte Gulf, Philippines. The morning fog clung to the waters as American battleships, cruisers, and destroyers formed a crescent across the Pacific. The Japanese Imperial Navy believed its coastal fortifications were unassailable, confident that the narrow channels and fortified islands would stop any invasion. But the Iowa-class battleships, armed with their 16-inch Mark VII guns, were about to rewrite that assumption forever. On board the USS Missouri, Captain Stuart Ingersoll surveyed the horizon, his binoculars trained on the distant island fortresses. Each turret bristled with firepower, 9 massive guns capable of hurling shells heavier than a small car over 20 miles. The air smelled of salt and oil, and the crew's tense silence reflected the gravity of the operation. The first target, the heavily fortified Japanese coastal battery on Samar Island. At exactly 6:30, the order came. Fire control officers calculated trajectories with mechanical precision. Rangefinders clicked. Electrical signals traced the path of each gun. And then, in unison, the Iowa, Missouri, and New Jersey fired. The explosion was instantaneous and absolute. Japanese soldiers, stationed behind bunkers reinforced with concrete and steel, barely had time to react. 16-inch shells penetrated observation posts, detonated supply depots, and shredded artillery emplacements. Entire gun emplacements were obliterated in seconds. The sheer velocity of the shells and the magnitude of their explosive power made traditional fortifications obsolete. On board the ships, sailors held onto rails as the battleships shuddered with the recoil of the massive guns. Each firing cycle created a vacuum of sound, a shockwave that rippled across the deck. In the distance, plumes of smoke and fire marked the destruction of the Japanese coastal line. By 7 o'clock, the entire battery had been neutralized. The next day, American forces encountered a different challenge. Japanese defenses along the Mindoro Strait included entrenched bunkers, minefields, and concealed artillery. Admiral William Halsey knew that sending troops without neutralizing these positions would be suicide. The solution? A relentless bombardment from sea. The Iowa-class battleships unleashed a continuous barrage. The 16-inch shells tore through reinforced bunkers with terrifying efficiency. The effect on Japanese strategy was catastrophic. Coastal artillery was no longer a deterrent. Troop deployments had to be reconsidered, as American naval gunnery could strike anywhere along the coast with deadly accuracy. Entire command centers were obliterated, leaving communication gaps that made coordinated defense nearly impossible. One sailor aboard the USS New Jersey later recalled the eerie sight. "We watched shells crash into cliffs, and entire mountains seemed to explode. Trees were stripped bare. Bunkers we could see in photos? Gone. It was like the land itself had been rewritten by fire." These attacks were not possible by heroism alone. They were the culmination of American industrial power. The 16-inch guns, each built at the Naval Gun Factory in Washington, D.C., required hundreds of engineers, machinists, and metallurgists to produce. The shells, weighing over 2,700 pounds, were manufactured in plants stretching from Pennsylvania to Illinois. Rail networks delivered them to ports, and skilled sailors loaded them into the battleships with military precision. This was American engineering applied on an unprecedented scale. Japan had focused on static fortifications, believing in the superiority of trained artillery crews. America's strength lay in scaling production, precision manufacturing, and coordinated deployment. Each battleship was a microcosm of the industrial complex that supported it, a floating testament to mass production, training, and tactical planning. The effect on Japanese strategy was catastrophic. Coastal artillery was no longer a deterrent. Troop deployments had to be reconsidered, as American naval gunnery could strike anywhere along the coast with deadly accuracy. Entire command centers were obliterated, leaving communication gaps that made coordinated defense nearly impossible. One sailor aboard the USS New Jersey later recalled the eerie sight. "We watched shells crash into cliffs, and entire mountains seemed to explode. Trees were stripped bare. Bunkers we could see in photos? Gone. It was like the land itself had been rewritten by fire." These attacks were not possible by heroism alone. They were the culmination of American industrial power. The 16-inch guns, each built at the Naval Gun Factory in Washington, D.C., required hundreds of engineers, machinists, and metallurgists to produce. The shells, weighing over 2,700 pounds, were manufactured in plants stretching from Pennsylvania to Illinois. Rail networks delivered them to ports, and skilled sailors loaded them into the battleships with military precision. This was American engineering applied on an unprecedented scale. Japan had focused on static fortifications, believing in the superiority of trained artillery crews. America's strength lay in scaling production, precision manufacturing, and coordinated deployment. Each battleship was a microcosm of the industrial complex that supported it, a floating testament to mass production, training, and tactical planning. By the time American battleships reached the shores of Luzon, Japanese coastal defense lines were effectively a shadow of their former might. The 16-inch guns had obliterated fortifications, artillery, and supply lines, creating a path for land forces that would have been unthinkable months earlier. The combined effect of these naval bombardments wasn't just destruction, it was demoralization. Japanese soldiers recorded the horror in diaries. "It is as if the ocean itself is alive, throwing thunder and fire upon us. Nothing can withstand it. We have failed." American reports from the same battleships emphasized precision and efficiency. Every salvo was calculated, every trajectory accounted for, and each shell delivered exactly where it was intended. In less than 2 months, the Iowa-class battleships had neutralized defenses that had taken Japan years to construct. This was fire from the sea, executed with surgical precision and overwhelming scale. The Japanese had built walls of steel and concrete. America's 16-inch naval guns turned those walls into dust, demonstrating that the true power of war lay not only in courage or numbers, but in engineering, industry, and precision execution. The Philippine campaign proved a simple but devastating truth. When industrial capacity, engineering genius, and tactical brilliance combined, no fortification, no matter how massive, could withstand it. And as Japan's coastal defenses smoked and crumbled, it became clear that the Pacific War had entered a new era, one where battleships armed with 16-inch guns could decide the fate of entire islands before the first troops set foot on the sand. January 9th, 1945, Lingayen Gulf, Luzon. The dawn was cold, gray, and eerily silent. Japanese soldiers crouched in bunkers reinforced with steel and concrete, listening to the distant roar of the ocean. For months, they had believed their coastal defenses were impregnable. Massive gun emplacements, pillboxes, and observation towers designed to repel any invader. Yet at that very moment, the USS Iowa, USS New Jersey, and USS Missouri were approaching from the horizon. Their 16-inch/50 caliber Mark 7 guns loaded, their crews trained, their industrial might unparalleled. Captain William T. Bill Halsey, Jr., aboard the Missouri, glanced at his charts. The Japanese coastal guns had a range of roughly 12 miles, but the American battleships could strike from 23. Distance was no longer protection. It was a liability. At the command of fire, 9 monstrous barrels unleashed their first shells. The sound was deafening, the recoil sending shudders through the decks. Yet the sailors moved with precision, operating like a single, synchronized organism. A 2,700-pound shell ripped through the air, striking the main coastal fortification with explosive force that obliterated bunkers and shredded concrete like paper. Japanese soldiers scrambled to return fire, but the shells struck faster than they could react. In minutes, one coastal battery after another disappeared in fireballs of smoke and dust. Observation towers, once vital for directing artillery, toppled like fragile toys. The thunder of 16-inch guns echoed across the Gulf, an auditory warning that nothing on land could withstand. Witnesses later recounted the chaos. Soldiers and laborers tasked with maintaining coastal guns fled or hid in foxholes as American shells tore through the landscape. Lieutenant Hiroshi Tanaka, stationed at a battery on Luzon, wrote in his diary, "We fired until our barrels were scorched, yet still the enemy shells struck as though guided by the hand of fate itself. The earth split open, our guns shattered, and our comrades vanished." The psychological effect was as decisive as the physical destruction. Entire defensive lines crumbled before the American invasion force even landed. The Japanese Imperial Army had underestimated not just the firepower, but the engineering, coordination, and industrial capability behind these floating fortresses. February 1st, 1945, Corregidor Island. The American assault on Corregidor marked another milestone. The Japanese believed their coastal artillery on the island could prevent any landing. They had fortified tunnels, casemates, and heavy gun emplacements, some designed to fire 14-inch shells at approaching ships. Yet the Iowa-class battleships, with guns capable of sending 16-inch shells 23 miles, made those defenses irrelevant. The USS Iowa's crew targeted each fortification with methodical precision. Observation reports were transmitted to fire control teams, who adjusted for wind, tide, and shell trajectory. A single salvo destroyed an entire gun battery, detonating stored ammunition and causing secondary explosions that wiped out nearby bunkers. Within hours, Corregidor's coastal defenses were reduced to rubble, and American forces landed with minimal resistance. Japan had relied on centuries of defensive doctrine, fixed positions, hardened emplacements, and highly trained artillery crews. America relied on something far more modern: industrial-scale firepower, precise engineering, and coordinated tactics that combine land, sea, and intelligence. Each 16-inch gun required meticulous manufacturing, barrels bored with extraordinary precision, shells cast and machined in factories from Philadelphia to Pittsburgh, and propellant charges calculated to fractions of an ounce. Yet it wasn't just the hardware. It was the system. Battleships were floating command centers. Radar operators, rangefinders, and gunnery officers coordinated with astonishing accuracy. Crews had been trained in months, drilling until the operation of a 16-inch turret became second nature. The result was a weapon that wasn't just destructive. It was predictable, reliable, and devastatingly effective. As American forces advanced along the Philippine coast, Iowa-class battleships struck every known Japanese position with relentless efficiency. Coastal artillery, which had been carefully constructed over years, was destroyed in days. Supply depots, barracks, and defensive fortifications vanished under explosive shells that weighed more than most automobiles. The speed and scale of destruction shocked Japanese commanders. Rear Admiral Masaru Homa, in correspondence, lamented that the Americans had brought weapons that made our best efforts seem childlike, our fortifications fragile, our soldiers helpless. The science of destruction. Each 16-inch shell produced an overpressure blast capable of collapsing reinforced structures. The armor-piercing design allowed the shell to penetrate thick concrete before detonating. With 3 guns per turret and 3 turrets per ship, the Iowa class could fire 9 of these devastating rounds in less than a minute. Multiply that across multiple battleships and entire coastal lines were annihilated almost simultaneously. This was more than brute force. It was a demonstration of applied science. Mathematics, metallurgy, physics, and mechanics combined to create a weapon of unprecedented accuracy and efficiency. Engineers on land monitored each firing, analyzing impacts, and making incremental adjustments. In this way, each successive salvo became more accurate, systematically reducing Japanese defensive capabilities. By the time American troops fully secured Luzon, most Japanese coastal defenses had been obliterated. Entire islands bore the scars of repeated bombardments. Craters where bunkers had stood, shattered artillery pieces, and scorched earth stretching miles. The psychological and physical devastation combined to make resistance almost irrelevant. Even decades later, veterans recalled the scale of destruction. Sailor Thomas Reynolds wrote, "The ground shook with every salvo. Trees were stripped of branches. Bunkers disappeared in clouds of dust." It wasn't just war. It was a statement that America could, and would, make the seas its own. The destruction of Japan's coastal defenses demonstrated a paradigm shift in warfare. Static fortifications, no matter how elaborate, were no match for mobile, industrially produced firepower. Battleships equipped with 16-inch guns didn't just fight battles. They reshaped strategy, morale, and the very concept of defense. The campaign also highlighted America's industrial genius. Factories churned out battleships, shells, and ammunition at a rate Japan could never match. Every destroyed coastal line represented not just a military victory, but a triumph of engineering, coordination, and the integration of science into warfare. By the end of the campaign, Japan's perception of invulnerability along its coasts had vanished. Islands that were supposed to be bastions of defense became open terrain for invasion. And through it all, the Iowa-class battleships and their devastating 16-inch guns stood as the ultimate expression of industrialized naval power. April 15, 1945, Luzon, Philippines. The sun rose over a landscape that was almost unrecognizable. The coastal defenses of northern Luzon had been reduced to twisted steel, shattered concrete, and scorched earth. Where once massive 14-inch guns and pillboxes had stood as symbols of Japanese military engineering, now only rubble remained. Japanese soldiers who survived the initial bombardments huddled in caves and foxholes, haunted by the roar of 16-inch shells from USS Iowa, USS New Jersey, and USS Missouri. Lieutenant Hiroshi Tanaka, who had survived the destruction of his battery days earlier, described the devastation in his diary. "We thought our positions were secure. We had spent months fortifying, reinforcing, and rehearsing for battle. But the Americans brought fire from the sea that we could not see, could not predict, and could not withstand. Our defenses, they were gone before we knew it." American forces did not immediately land. Instead, they allowed the battleships to continue a systematic shelling campaign. Every known defensive position was targeted, including hidden machine gun nests, ammunition depots, and coastal artillery emplacements. Each salvo of the 16-inch guns delivered precise, calculated destruction, a combination of brute force and scientific accuracy. At the shore, observers recorded how the Japanese defenses crumbled. Observation posts that had guided their own artillery now lay in ruins. Soldiers fired sporadically, often without sight of their targets. Ammunition exploded prematurely, a terrifying result of the concentrated bombardment. Engineers analyzing the bombardment later noted the precision of the destruction. Every structure hit was obliterated to the extent that it could no longer be repaired or reused. The psychological impact was immense. Survivors spoke of constant fear, exhaustion, and the demoralization of fighting a seemingly unstoppable enemy. Private Kazuo Saito, stationed near Lingayen Gulf, recounted, "We dug trenches, we reinforced bunkers, but nothing could withstand their shells. We could hear them coming long before they struck, but did not prepare us. Each explosion killed comrades, destroyed shelter, and broke our will. It was as if the earth itself, turned against us. This was warfare unlike any before, an industrialized, mechanized assault that combined human courage with engineering precision. The Japanese coastal defenses were meticulously designed to withstand conventional attacks, but nothing in their doctrine could counter mobile, massive-caliber battleships capable of firing with devastating accuracy from distances beyond their range. While the battleships maintained constant bombardment, American infantry began landing on lightly defended beaches. The obliteration of the coastal artillery meant minimal resistance for the troops. Units from the 6th Infantry Division advanced inland, encountering scattered pockets of Japanese resistance, but nothing approaching the prepared, fortified lines they had expected. The success of the landings was directly linked to the destruction wrought by naval gunfire. Each artillery emplacement, neutralized from the sea, represented a safe corridor for the advancing soldiers. The integration of naval and ground operations highlighted a crucial shift in military strategy. Industrialized firepower could now dictate the tempo of war. Behind the decks of the battleships, engineers and gunnery officers studied every impact, adjusting range, bearing, and shell type. The combination of 16-inch armor-piercing shells and high-explosive rounds ensured that both reinforced structures and unarmored positions were destroyed efficiently. Every turret, bunker, and observation post became a data point, refined in real time to maximize the effectiveness of each strike. Naval historian Samuel Eliot Morison later remarked, "The brilliance of the 16-inch guns was not just in their destructive power, but in the system that employed them. It was industrial war applied to the sea, a machine of destruction honed to perfection." By late April, the once formidable Japanese coastal line was no more. Pillboxes had been flattened, artillery destroyed, and supply depots annihilated. Even the tunnels and fortified caves, designed to shelter soldiers and munitions from bombardment, were compromised by the concussive force of repeated 16-inch shell impacts. The destruction was not merely physical. Japanese strategic planners were forced to acknowledge a fundamental truth. Static coastal defenses, no matter how elaborate, were obsolete against modern, industrially produced naval artillery. The lessons were clear. Mobility, industrial capacity, and precision engineering had rendered centuries of defensive doctrine irrelevant. The obliteration of Luzon's coastal defenses marked a watershed moment in naval warfare. It demonstrated the unmatched effectiveness of industrial-scale firepower, emphasizing the importance of logistics, training, and coordinated operations. While Japanese engineers had relied on meticulous fortification and human skill, American success rested on integrated systems thinking, where battleships, artillery crews, and industrial production were synchronized to achieve maximum effect. Each 16-inch shell fired was the product of months of labor in American factories. Barrels bored to exact specifications, propellant charges carefully measured, and shells machined with extraordinary precision. The efficiency and scale of production allowed repeated, sustained bombardment, a tempo Japan simply could not match. The story of Luzon's coastal destruction remains a testament to engineering, coordination, and strategic foresight. The obliteration of Japan's coastal line highlighted the shift from traditional fortifications to industrialized, integrated warfare. It proved that preparation alone was insufficient when faced with enemies who could leverage science, manufacturing, and logistics on an unprecedented scale. The survivors, both Japanese and American, would carry these lessons into the post-war world. Japan recognized the vulnerability of fixed defenses, and the United States saw the decisive advantage conferred by industrialized firepower. The 16-inch naval guns had not just destroyed coastal positions. They had reshaped military thought for decades to come. May 10, 1945, northern Luzon, Philippines. The morning fog hovered over shattered bunkers and collapsed artillery positions. Japanese commanders scrambled to understand the scale of the disaster inflicted by American 16-inch naval guns. General Tomoyuki Yamashita, commanding forces in Luzon, convened an emergency meeting with his divisional officers. The coastal defenses, meticulously constructed over months, had been obliterated with a single, relentless barrage. Colonel Masao Fujimoto, responsible for the northern coastal battery at Lingayen Gulf, described the shock in his diary. "I have never seen such destruction. Our positions, fortified with steel and concrete, meant to resist any assault, are now nothing but debris. Our men are shaken, morale broken. We must find new ways to resist, but time and resources are against us." Japanese engineers and officers faced a daunting task: how to defend against an enemy capable of leveling their positions from beyond the horizon. Static artillery emplacements, once considered unassailable, had proven catastrophically vulnerable. The new doctrine emphasized mobility, camouflage, and dispersion. Engineers dismantled remaining guns and relocated them inland, hidden in forests or behind hills, to reduce visibility to American spotters. Private Hiroshi Nakamura, who had survived the bombardment, recounted, "We dug new trenches in the jungle. Artillery was moved piece by piece. We covered positions with nets, bamboo, and foliage. It was like fighting ghosts. Every move was invisible to the Americans, yet we knew they could destroy us in an instant if discovered." The Japanese army transitioned from relying on fixed fortifications to hit-and-run tactics, using small teams to harass American supply lines and observation posts. Infantry units trained in rapid redeployment moved under the cover of night, attempting to exploit any gaps in American vigilance. The challenge was immense. American battleships continued to dominate the seas, their 16-inch guns capable of firing over 20 miles with pinpoint accuracy. Rear Admiral Shigeru Fukuda, observing the unfolding disaster from his command post, lamented, "We are no longer defending positions. We are defending shadows. The Americans' firepower is beyond comprehension. We must innovate, or we are doomed." Japanese engineers improvised rapidly. They reinforced tunnels, created underground bunkers, and developed decoy installations. Fake artillery positions, complete with wooden replicas and smoke generators, were built to draw fire away from real positions. Engineers calculated angles and distances meticulously, hoping to trick American spotters into wasting valuable shells on non-existent targets. Lieutenant Hideki Sato led a team responsible for tunnel fortifications near the Lingayen Gulf coastline. He noted in his field journal, "We learned quickly. Every real battery must be hidden. Every false battery must convince the enemy it is real." Precision and deception became our new weapon. Despite Japanese adaptations, the industrial might of the United States was overwhelming. American battleships continued their systematic bombardment, guided by aerial reconnaissance and spotter planes. Every adjustment, every recalculation by Japanese engineers was met with counters from the Americans. Firepower delivered faster than any repair could be completed. Lieutenant Commander James H. Smith of USS Missouri described the process. "We observed patterns. The Japanese moved positions, but the range and precision of our 16-inch guns allowed us to adjust within minutes. Every new target was calculated, every shell a guided solution to a tactical problem. It was industrial engineering applied directly to war." The human cost of adaptation was immense. Japanese soldiers endured constant stress, fear, and physical exhaustion. Shifts in defensive positions required night marches, labor-intensive construction, and continuous vigilance. Food shortages and casualties exacerbated the psychological strain. Soldiers wrote letters home that were full of despair and uncertainty, realizing that industrially produced firepower could neutralize human ingenuity and bravery alone. Sergeant Kenji Hasegawa captured this sentiment. "We fight with everything we have, but it is like throwing pebbles at a hurricane. We can hide, we can move, but they can reach us anywhere. Fear is constant, and courage must be measured against despair." By late May, Japanese defensive doctrine had shifted significantly. Traditional coastal artillery, once the centerpiece of strategy, became secondary to mobile, dispersed, and concealed operations. Soldiers were trained in small unit tactics, Engineers focused on underground fortifications, and decoy installations were deployed widely. It was a dramatic evolution, from static fortifications to adaptive, guerrilla-style defense. Naval historians later analyzed this period and concluded that while Japan's adaptation slowed American advances in localized areas, it could not overcome the massive disparity in industrial capacity and firepower. The 16-inch guns of the U.S. Navy had changed the calculus of warfare, proving that industrialized artillery could decisively shape the battlefield. The destruction of Luzon's coastal defenses, coupled with Japanese adaptation efforts, became a critical case study in modern warfare. Militaries worldwide observed that fixed fortifications were vulnerable to industrialized precision artillery. Mobility, redundancy, camouflage, and deception emerged as key principles in post-war defensive planning. Admiral Chester W. Nimitz later commented in a debrief, "The battle for Luzon taught us that technology and production capacity can define the outcome of a campaign more than sheer numbers." The 16-inch guns were not merely weapons. They were instruments of strategy, planning, and execution, demonstrating the decisive role of industrial power in modern warfare. June 5, 1945, Luzon, Philippines. The morning mist clung to the scorched coastline as American battleships prepared for the final series of bombardments. The remnants of Japanese coastal defenses were scattered, hidden in tunnels, and camouflaged beneath foliage. But the 16-inch guns of the USS Iowa, USS New Jersey, and USS Missouri were relentless. Each shell fired carried the weight of months of engineering precision, industrial power, and strategic foresight. Captain William S. Benson of USS New Jersey wrote in his log, "Today we finish what we started. Every target is within range, every impact calculated. The coastal line is crumbling. Their resistance is fading. This is industrial warfare at its peak." American gunners targeted the remaining artillery positions, supply depots, and observation posts. Even hidden gun emplacements were destroyed with repeated, calculated shelling. The Japanese soldiers still defending these positions were exhausted, demoralized, and outmatched. Lieutenant Hiroshi Tanaka, reflecting on the final bombardments, wrote, "We had hidden, we had tried to deceive, we had tried to survive. But it was not enough. Their shells found us everywhere. There was no corner of the coastline safe. It was as if the sky itself rained death upon us." The combination of long-range targeting, high-explosive rounds, and sustained barges ensured complete neutralization. Any attempt to repair or reinforce positions was rendered futile by the sheer rate of fire. Engineers and gunners aboard the battleships continuously calculated adjustments to maximize efficiency, proving that industrial capacity could directly dictate the outcome of engagements. The destruction of the coastal line was not merely physical. The psychological toll on Japanese forces was catastrophic. Officers struggled to maintain order, soldiers faced overwhelming fear, and morale collapsed. The coastal line had been designed to intimidate and halt invasion, but its destruction demonstrated the futility of fixed fortifications against modern, industrialized firepower. General Tomoyuki Masha admitted in later reflections, "The Americans have shown that preparation alone cannot counter precision, production, and coordinated power. Our defenses were meticulous, yet insufficient. The nature of war has changed. With the coastal line obliterated, American infantry and armored units advanced with minimal resistance. Supply chains and forward bases were secured, ensuring a smooth operational corridor along the northern Luzon coast. The effectiveness of the 16-inch guns directly facilitated the rapid establishment of beachheads, proving that naval artillery could reshape land campaigns." Lieutenant Commander James H. Smith observed, "Our firepower removed obstacles before our troops even landed. Positions that would have cost hundreds of lives to take were neutralized from the sea. This is precision, planning, and production combined, a revolution in warfare." The success of the bombardments on Luzon showcased the industrial might of the United States. Each 16-inch shell was a product of advanced metallurgy, mass production, and meticulous quality control. Unlike Japanese defenders, who relied on skill and ingenuity to fortify positions, the Americans leveraged industrial capacity to maintain a tempo of destruction no human skill alone could match. Naval historian Samuel Eliot Morison later summarized, "The 16-inch guns were instruments of strategy, extending the reach of industrialized warfare from factory to battlefield. They made history by demonstrating that production, coordination, and engineering could achieve results previously considered impossible." The obliteration of Japan's coastal defenses during the Luzon campaign had far-reaching implications. Militaries learned that fixed fortifications were vulnerable to industrial-scale precision weaponry. The integration of technology, production, and strategic planning became a blueprint for modern combined arms warfare. Even today, naval and military academies study the Luzon bombardments as a case study in systems-based warfare. Every shell, ship, and observation post functioning as part of an integrated operation. The campaign demonstrated that industrial engineering and logistical excellence could achieve what traditional tactics could not. The destruction of Japan's coastal line is a testament to the power of planning, innovation, and industrial capacity. Ordinary sailors, engineers, and gunners aboard American battleships achieved extraordinary outcomes, proving that warfare was no longer just about courage and tactics, but about precision, production, and persistence. Private Kazuo Saito, one of the surviving Japanese soldiers, would later reflect, "We fought with bravery, but they fought with an entire nation behind their guns. Their fire never stopped. Their power was relentless, and we could not match it. The coastline is gone, and with it, our hope of defending it." If you've been captivated by the sheer power of these 16-inch naval guns, the story doesn't end here. The lessons of Luzon resonate far beyond World War II. They teach us about the marriage of engineering, production, and strategy, and how industrial might can alter the course of history. Make sure to watch the full series, because understanding how battles are won before the first shot lands is as crucial as witnessing the firepower itself.